we want to tackle the following problem. We want to show that the function f defined by e to the minus 1 over x squared for positive x and 0 for non-positive x is differentiable for all values of x. So the first thing we should do is look at our function. For x strictly positive, f of x is just the differentiable function e to the minus 1 over x squared. It's differentiable because it's the composition of the differentiable function e to the x with the differentiable function 1 over x squared. So f of x is differentiable for all positive x. Similarly, f of x is just 0 for all negative x, so f is differentiable there as well. So the only place where f of x might not be differentiable is at x equals 0. So I'm just going to summarize by just saying that f is clearly differentiable for non-zero x. But we need to check what happens at f of x, or we need to check what happens at x equals 0. So in order to figure out whether the function f of x is differentiable at 0, we should use the definition of the derivative. So the definition of the derivative says that we should look at the limit as h approaches 0 of f of 0 plus h minus f of 0 over h. I've taken the liberty of simplifying 0 plus h to h and using the fact that f of 0 is equal to 0. So we want to evaluate this limit. So we write out, oh, I guess not yet. The first thing we want to do is look at the left-hand limit. And since f of x is 0 if x is less than or equal to 0, f of h over h is just 0 for all h, so the left-hand limit's clearly 0. For looking at the right-hand limit, we write in e to the minus 1 over h squared instead of just f of h. And we want to evaluate this limit as h approaches 0 from the right. So in order to simplify the calculation of this limit, we need to make the substitution t equals 1 over h. If t is 1 over h, then the numerator is e to the minus t squared. The denominator becomes 1 over t, so we're just going to flip that up to the numerator. And h goes to infinity now instead of to 0. So you get the limit as t goes to infinity of e to the minus t squared times t. And since e to the minus t squared decays a lot faster than t grows, this limit is also 0. So the left-hand limit is 0, and the right-hand limit's also 0. Therefore, we conclude that the function is differentiable at 0.